Welcome to our latest video on the topic of using precipitation reactions to identify transition metal ions. This video is suitable for GCSE students. By the end of this video lesson, you should be able to describe the general properties of transition metals, including their ability to form ions with different charges. You should also be able to understand that precipitation reactions with aqueous sodium hydroxide can be used to identify the presence of Cu2+, Fe2+, and Fe3+ ions, and be able to describe these reactions with word, chemical, and ionic equations. And finally, you should understand the properties and uses of copper, titanium, and the alloy steel. Now, we've learned previously, as part of the acids, bases, and salts topic, that an insoluble salt or an insoluble solid formed by adding two soluble salts together is called a precipitate. Now, a precipitation reaction is any chemical reaction when two solutions, two soluble compounds, are mixed together and an insoluble solid forms. And the precipitate is the insoluble solid that forms as part of this precipitation reaction. Now, in this lesson, we're going to look at how precipitates can be used to identify transition metal ions. Now, in previous lessons, we've learnt that precipitation reactions are often used as chemical tests, and specifically to test for the presence of different ions. So, for example, a chloride ion can be tested by using silver nitrate. Now, if you add silver nitrate to any solution that contains a chloride ion, so for example sodium chloride, you would form silver chloride, which is a white insoluble solid, and that is called a precipitate. And you can also use silver nitrate to test for a bromide ion and an iodide ion, because you would form silver bromide, which is a cream solid, a cream precipitate, and silver iodide, which is a yellow insoluble solid, a yellow precipitate. Now, we've also seen in previous lessons that you can use a precipitation reaction to identify the presence of a sulfate ion. A sulfate ion is SO4 2-. And if you add barium chloride or barium nitrate to any solution containing a sulfate ion, you will get a white precipitate. And the white precipitate indicates that you formed barium sulfate and you have a sulfate ion present. So we've seen that precipitation reactions are very important in identifying the presence of ions. And in this lesson, we're going to look at their use to identify the presence of transition metal ions. So if we're going to look at how precipitation reactions can be used to identify transition metal ions, it's important that we understand what we mean by transition metals. Now, transition metals are the large group of metals located between groups 2 and 3 in the periodic table. Now, these elements have physical properties that are very typical of metals. So, for example, they have high melting points, they conduct electricity, they conduct heat, they're ductile, which means they can be drawn into wires, they're malleable, which means they can be hammered into different shapes, and they're very strong. So now let's look at some examples of transition metals. So the first example we're going to look at is copper, which has the symbol Cu. And copper is a very good conductor of heat and electricity. It's malleable, which means we can hammer it into different shapes. It's ductile, which means it can be drawn into wires. And it's got an attractive orangey brown colour. And it has lots of uses. Now, copper is used in electrical wiring because it's a good conductor of electricity and it's also ductile. It's also used in hot water pipes because it's a good conductor of heat. And it's also used in making pots and pans and kettles because of its attractive appearance, and also because, again, it's a good conductor of heat. Now, we've seen previously in this module that copper is purified by electrolysis, and this is needed when making high specification electrical wiring. Now, another transition metal you need to be aware of is titanium, and titanium is hard, strong, has a low density, is resistant to corrosion, and has a high melting point. Now, titanium has the chemical symbol Ti, and because of its properties, it finds uses in the aerospace industry and also making artificial limbs such as artificial hips. Now, we also come across titanium in smart materials because titanium, when mixed with nickel, forms the alloy nitinol. And nitinol is a shape memory alloy. And this is a material that regains its original shape on heating. And we use nitinol in spectacle frames because if you twist them out of shape, you can put them in hot water and they regain their original shape. Now, another transition metal you need to be aware of is iron, and iron has the chemical symbol Fe, and we've come across iron before in the extraction of metals unit, and we learned that iron is extracted from its ore in the blast furnace, and iron is used to make the alloy steel. Now remember, alloys are mixtures of metals and other elements, and steel is hard and strong and has lots of uses. There are different types of steel. For example, there's mild steel, which is iron plus around about 0.25% carbon, and that's easily shaped and not very brittle. And there's high carbon steel, which has a higher percentage of carbon, which is hard and brittle. And then we have things like cast iron and stainless steel, where we have other metals such as chromium and nickel, and that's tough and doesn't rust, it doesn't corrode. Now, steel is used in making bridges, it's used in making cars, it's used in making ships, it's used in making household appliances such as washing machines, cookers, etc. Now, although transition metals have typical properties of metals, they do have some unusual properties, and we call these chemical properties. Now, transition metals can form more than one type of ion when they react. So, for example, iron can be Fe2+ or Fe3+ when it's part of a compound. Chromium can be Cr3+ or Cr6+, for example, when it's part of a compound. And this is a common feature of transition metals. Now, transition metals also have coloured compounds. So, for example, copper sulfate is blue, potassium dichromate is orange, nickel sulfate is green. So this is another chemical property of transition metals, the fact they have coloured compounds, and we utilise this in some of their uses. Now, another property of transition metals is the fact that they have catalytic properties. Their compounds and sometimes the metals are used as catalysts. Catalysts are substances that speed up chemical reactions and are not used up in the reaction. They don't take part in the chemical reaction itself. So, for example, iron is used as a catalyst in the production of ammonia, an important chemical that we need to make fertilizers. Nickel is used as a catalyst for the hydrogenation of alkenes, adding hydrogen to compounds with carbon-carbon double bonds, and that's important in the margarine industry. Now, other examples of transition metal catalysts include vanadium 5 oxide, which is used in the manufacture of sulfuric acid, and platinum, which is used in catalytic converters, removing harmful products produced in cars. So at GCSE, we want you to be aware that transition metals have typical metallic properties. They have high melting points, conduct electricity, conduct heat, are malleable, ductile, etc. But we also want you to be aware that transition metals have these special chemical properties. For example, their ability to form more than one type of ion, their ability to have coloured compounds, and the fact that transition metals are able to speed up chemical reactions as metals and as also metal compounds, their catalytic properties. So we're now going to look at how precipitation reactions can be used to identify transition metal ions. Now, transition metal compounds and solutions are coloured, and for the exam you have to be able to identify Cu2 plus ions, Fe2 plus ions and Fe3 plus ions by reacting these solutions and compounds with sodium hydroxide and forming characteristic coloured precipitates. Now, when you add aqueous sodium hydroxide to solutions containing either copper 2 plus, Fe2 plus or Fe3 plus ions, you will form insoluble metal hydroxides, which are called precipitates, and the colours of these precipitates will help you identify which ions are present. So for example, when you add sodium hydroxide to copper 2 plus ions, you form copper 2 hydroxide, which is an insoluble solid. It's a precipitate. When you add sodium hydroxide to iron 2 solutions, you form iron 2 hydroxide, which is insoluble. And when you add sodium hydroxide to iron 3 solutions, you form iron 3 hydroxide, which is also an insoluble solid or precipitate. So now let's see these reactions in action. So in this test tube, we're going to put some copper 2 plus solution, copper sulfate, and we're going to add aqueous sodium hydroxide. And as soon as we add the aqueous sodium hydroxide, which contains OH minus ions, we form a pale blue precipitate. There's an insoluble solid in the test tube. And the insoluble solid, the precipitate that we form, is copper 2 hydroxide, which has the chemical formula CuOH in brackets 2. So this slide summarizes the reaction that's taken place. So copper 2 sulfate has been reacted with sodium hydroxide to form the insoluble solid, the precipitate, copper 2 hydroxide, and sodium sulfate. And the chemical equation is CuSO4 plus NaOH forms CuOH2, and the OH is in brackets, and Na2SO4. Now we have to balance the equation because on the right hand side we have Na2SO4, so there's 2 sodiums, and there's only 1 sodium on the left, so we put a 2 in front of the NaOH, and then the equation is balanced because we have 1 copper on either side of the equation, we have 1 sulfur on either side of the equation, we have 6 oxygens on either side of the equation, 2 sodiums on either side of the equation, and 2 hydrogens on either side of the equation. So the equation is balanced. Now compounds and solutions that contain Cu2 plus ions, such as copper sulfate, are blue in appearance, and the presence of the Cu2 plus ion can be identified by this reaction with aqueous sodium hydroxide and the formation of the pale blue precipitate of copper 2 hydroxide. Now we've seen previously when studying precipitation reactions that ionic equations are used to describe these reactions. Now in an ionic equation I just have to identify what the precipitate is. So in this case it's copper 2 hydroxide, CuOH2, and I write this down and then I draw an arrow to this compound. So I'm going to do this now, and I'm just going to write down the 2 ions that form copper hydroxide. So the 2 ions are Cu2 plus and OH minus. So I'm going to write these ions down in the equation, and you can see I've got 2 OHs, so therefore I must have 2 OH minus ions. Now I'm also going to include state symbols here. So AQ stands for aqueous, which means we have solutions of these ions, and the S stands for solid, which means we have an insoluble solid or precipitate. So now let's look at what happens when we take a solution of iron 2 plus ions. So we're going to use iron 2 sulfate for this, and we're going to put a few drops of iron 2 plus ions, iron 2 sulfate into the test tube, and then we're going to add aqueous sodium hydroxide, and this time we get a green precipitate, and it's quite dark green. Sometimes it's referred to as a dirty green precipitate forming. And this dirty green precipitate is iron 2 hydroxide. And this is the chemical test for iron 2 plus ions. Now the last experiment we're going to do is we're going to put a solution of iron 3 chloride into a test tube. Now iron 3 chloride contains Fe3 plus ions, and we can identify the presence of these ions by once again adding sodium hydroxide solution to it. So if we put a solution of iron 3 chloride into a test tube and we add aqueous sodium hydroxide, this time we get a brown insoluble solid forming, a brown precipitate. And this is rust-like in appearance, and this is because we form iron 3 hydroxide, which is commonly known as rust. So now let's summarize what we've seen in these experiments. So in experiment 1, we added a few drops of sodium hydroxide solution to a few drops of copper 2 sulfate solution, and we formed a pale blue insoluble solid or precipitate. And that precipitate tells us that we had Cu2 plus ions present, and the name of the precipitate that we formed was copper 2 hydroxide. And this is a chemical test for Cu2 plus ions. Now in experiment 2, we added a few drops of sodium hydroxide solution to a few drops of iron 2 sulfate. Now iron 2 sulfate solution contained Fe2 plus ions, and we formed a green precipitate. Now this was quite dark in appearance and is often referred to as a dirty green precipitate. And this indicates the presence of Fe2 plus ions, and the name of this insoluble solid or precipitate is iron 2 hydroxide. And the iron 2 is important to put the 2 bit because that indicates that we have Fe2 plus ions present. Now in experiment 3, we added a few drops of sodium hydroxide solution to a few drops of iron 3 chloride solution, and we formed a rusty brown precipitate. Now the iron 3 chloride solution contained Fe3 plus ions, and the precipitate that we formed was iron 3 hydroxide. And once again, it's important to include the 3 here in the name to show the presence of Fe3 plus ions. So now let's work out the chemical formula of the precipitates. So the hydroxide ion is OH minus. So in copper 2 hydroxide, we have Cu2 plus ions and OH minus ions. And the chemical formula is CuOH2. And this is because I need 2 OH minus ions to cancel out the 2 plus charge. Now it's important here to put the OH in brackets because we need 2 OHs. And in the second precipitate we have Fe2 plus and OH minus ions present. So the formula is FeOH2 because I need 2 OH minuses to cancel out each 2 plus charge on the Fe. And in the last precipitate we have Fe3 plus ions and OH minus ions, so the chemical formula of the precipitate is FeOH3. Now any compound or solution that contains Cu2 plus ions will be blue in appearance, and if they contain Fe2 plus ions they'll be green in appearance, and Fe3 plus ions they'll be brown in appearance. However, to confirm the presence of these ions we need to react the ions with hydroxide ions, and it's usual to use sodium hydroxide solution for this. However, any hydroxide solution would work. So for example, if we added calcium hydroxide solution to copper 2 plus ions, we'd still get the pale blue precipitate, which would show us that copper 2 plus ions were present. So now let's test your understanding of what we've learned in this video with some practice questions. So here's our first practice question, and there are 2 parts to this, part A and part B. So here's part A. So read through the question, pause the video and have a go at it, and then we'll look at part B, and then we'll go through both parts A and B together. So here's part B. So once again, read through the question, pause the video have a go at it, and then we'll go for the answers to parts A and B. So question 1 says that niobium is a typical transition metal, and it's asking you to put a tick next to each of the 4 properties in the table that you would expect for niobium. So the 4 properties that it would have as a typical transition metal would, it would conduct heat, 1 mark for that. It would form coloured compounds, 1 mark for that. It would have a high melting point, 1 mark for that. And it would be strong, 1 mark for that. So there are 4 marks there, 1 mark for each property. So now let's go for the answer to part B. So for question B, it says transition elements and their compounds have many uses. Iron oxide and cobalt oxide have been added to the glazes of pottery for hundreds of years. Statewide transition metal oxides are added to pottery glazes. Now all the question is trying to get here is for you to understand that compounds are coloured, so that would give the nice coloured glaze to pottery. So all you had to say for 1 mark is the compounds are coloured. So here's our second practice question. Once again, read through the question, pause the video, have a go at it, and then we'll go through the answers. So now let's go through the answers to question 2A and 2B. So for 2A, you're asked to write a word equation to describe the reaction of iron 2 sulfate and sodium hydroxide. So the equation would be as follows. Iron 2 sulfate plus sodium hydroxide forms iron 2 hydroxide and sodium sulfate. Now this word equation gets you 1 mark. Now as there are 2 different forms of iron in a compound, iron 2 plus and iron 3 plus, we need to make it clear in the word equation that we are dealing with iron 2 here. That's why we put iron 2 sulfate and iron 2 hydroxide in the equation. Now for part B, you're asked to write a word equation for iron 3 chloride and sodium hydroxide. So it would be iron 3 chloride plus sodium hydroxide makes iron 3 hydroxide and sodium chloride. And once again, there's 1 mark for the word equation. So here's our next practice question. Once again, read through the question, pause the video, have a go at it, and then we'll go for the answers. So now let's go for the answers to question 3A and 3B. So you're asked to write chemical equations to describe the reactions that take place between iron 2 sulfate and sodium hydroxide and iron 3 chloride and sodium hydroxide. So I've written word equations here to help me. So I now have to replace each of the words with symbols. So for iron 2 sulfate, the 2 ions are Fe2 plus and SO4 2 minus. Because they have the same charge, they cancel out. So the formula of Fe2 sulfate is FeSO4. Now for sodium hydroxide, the 2 ions present are Na plus and OH minus. Now once again, because these have the same charge, they cancel out. So the chemical formula of sodium hydroxide is NaOH. Now when iron 2 sulfate reacts with sodium hydroxide, we make the precipitate iron 2 hydroxide. So the 2 ions for iron 2 hydroxide are Fe2 plus and OH minus. Now I can either swap the charges over here to work out the formula, or I can say how many OH minus ions do I need to cancel out the 2 plus charge? 2. So the formula is FeOH2. I put the OH in brackets because I need 2 OHs. I don't need 1 oxygen and 2 H's. And the last formula I need to write is sodium sulfate. Now sodium has a charge of 1 plus, so it's Na plus. Sulfate is SO4 2 minus. If I swap the charges over, I get the chemical formula Na2 SO4. Or once again, I can look at it and go, how many Na plus ions do I need to cancel out the SO4 2 minus ion? So that's my chemical formula. It's not balanced because I have 2 sodiums on the right. I need 2 on the left, so I put a 2 in front of the NaOH. And then the equation is balanced because I have 1 ion on either side, I have 2 sodiums on either side, I have 6 oxygens on either side, and I have 2 hydrogens on either side, and that equation is balanced. So now let's do the equation for B. So iron 3 chloride has a formula of FeCl3 because we have Fe3 plus and Cl minus ions. Swap the charges, FeCl3. Sodium hydroxide has a formula of NaOH because we've already worked that out. This time we have to work out the formula of iron 3 hydroxide. So it's Fe3 plus, OH minus ions. Swap the charges over. The chemical formula is FeOH3. Now once again, when writing the formula, I can look at this as how many OH minus ions do I need to cancel out the 3 plus charge? 3. So therefore the formula is FeOH3, and I put the OH in brackets because I need 3 OHs. And then I have to write the formula of sodium chloride. So the 2 ions are Na plus and Cl minus. They have the same charge, so it cancels out. So the formula is NaCl. Now all I have to do is balance the equation. I've got 3 chlorines on the left and 1 on the right, so therefore I have to put a 3 in front of the NaCl. And then when I put a 3 in front of the NaCl, I need a 3 in front of the NaOH so that the sodiums and the oxygens and hydrogens are balanced. And that's my final equation, and I get 1 mark for writing all the formula for both of these equations. So if I get all the correct formula, I get 1 mark, and there's 1 mark for correct balancing in each of these equations. So here's our final 2 practice questions. So once again, read through the questions, pause the video, have a go at them, and then we'll go through the answers. So now let's go for the answers to question 4 and 5. So in question 4, a solution is suspected to be iron 2 sulfate, FeSO4, and you're asked to describe how sodium hydroxide solution could be used to show the presence of the iron 2 ions. Well, if you add sodium hydroxide to iron 2 sulfate, you will get a green precipitate because this is the test for iron 2 plus ions. So if you said you get a precipitate, you get 1 mark, and if you correctly identified that it would be green, you get the 2nd mark. So there's 2 marks for that. Now for part 2, you have to give the balanced ionic equation for the reaction that takes place. So you have Fe2 plus ions reacting with 2 OH minus ions to form FeOH2. Now this is worth 3 marks, and 1 mark was given for the reactants. So if you correctly said Fe2 plus reacts with OH minus ions, 1 mark for FeOH2, the correct formula, and 1 mark for the balancing. So now let's go for the answer to question 5. Now this says, when sodium hydroxide is added to iron 3 chloride, a rusty brown precipitate is formed. Write a balanced ionic equation for the reaction takes place. So this would be Fe3 plus 3 OH minus ions forms FeOH3. And once again, the OH is in brackets. Now, once again, there's 1 mark for the reactants, Fe3 plus and OH minus ions, 1 mark for the product, FeOH3, and 1 mark for the balancing. Now, in these questions, no marks were deducted if you didn't include state symbols. However, if you want to include the state symbols for each of these ionic equations, the reactants would be AQ each because they're aqueous solutions, and the 2 precipitates, FeOH2 and FeOH3, would be solids, so you'd put a little S as a state symbol. So that concludes our video lesson. So after watching this video, you should be able to describe the general properties of transition metals, including their ability to form ions with different charges. You should also be able to understand that precipitation reactions with aqueous sodium hydroxide can be used to identify the presence of Cu2+, Fe2+, and Fe3+ ions, and be able to describe these reactions with word, chemical, and ionic equations. And finally, you should be able to understand the properties and uses of copper, titanium, and the alloy steel. So that concludes this video lesson. So please check out our YouTube channel, Dr. O Chemistry, which has lots of GCSE, AS and A-level videos, and our Twitter site @RadaChemistry.